production is pulled together.
It's going to be a steel bridge.
The way the cockpit is designed.
The highest rated green building in the world.
Welcome to HEC TV Live. Welcome to HEC TV Live, where today we're at the St. Louis Science Center as we investigate climate change as part of the Climate Change Exhibition, which is exactly the video you're seeing here now. You would be, if you were at St. Louis, walking into the Science Center, their Exploradrome section of the museum here, you'd have the opportunity to walk into the exhibition and begin to think about how climate change has happened over the course of the last couple hundred years and how man has been affecting that climate change. So the video you're seeing now takes you into the beginning of that, where you see how our carbon footprint has increased over time as you look at those numbers increase, and you see how man's activities has definitely made a difference. In today's program, we're going to be exploring three specific aspects of the whole big topic of climate change. We're going to talk a bit about carbon footprint, we're going to talk a bit about rising sea levels, and we're also going to have the chance to talk about an alternative form of energy as well. Hi everybody, I'm Tim Gore, your host for HEC TV Live, and I'm very happy to welcome you to the Climate Change Exhibition here at the St. Louis Science Center. I'm being joined by two experts who will be part of today's program. Carol Valenta, who's the Associate Director from the St. Louis Science Center. Carol, thanks so much for being here.
It's my pleasure. I'm delighted to be here.
And Dr. Bill Dannevik, Meteorology Professor from St. Louis University. Bill, thank you so much for being here.
Glad to be with you.
Those folks are going to be able to answer your questions as we talk about climate change today. It's a broad topic, but we're just going to deal with the three specific aspects of the program: carbon footprint, sea level rise, and potential solutions. And we're going to have one very important solution we're going to check specifically. If you're watching us via television or the web, then feel free to email us your questions and comments throughout the program to live@hectv.org. That's live@hectv.org. We look forward to that interaction. We have a couple of interactive video conference schools joining us today as well. And we're going to go right to them now, because the first topic we want to talk about that kind of like sets the groundwork, so to speak, for the entire exhibition is for everybody to have an understanding of the difference between climate and weather. So I first want to go to Science Park High School in Newark, New Jersey, where I believe Salam Thomas, I hope Salam I've just pronounced your first name correctly, is going to give us your information about what you all think is the difference between climate and weather. Take it away, Mr. Thomas.
Hi, I'm speaking on behalf of Salam Thomas, and we represent Science Park High School, particularly an AP Environmental class and a biology class. Thank you.
So basically, the difference between climate and weather is what occurs on a daily basis. It's the rain, it's precipitation, the things that occur in our natural environment on an everyday type of routine. But climate is the overall weather in a region. So we may live in a subtropical region or a tropical region. It depends on, how close you are to the equator, all of that good stuff. So, yeah.
Great, thank you very much. That's great information in terms of the basic difference between climate and weather. They're talking about, climate being a longer period of time overall, weather being specific to an event. Like, for example, it's sunny here today and it might be raining tomorrow. How important is it for us to understand the relationship between climate and weather? And should I really be looking, Dr. Dannevik, at individual weather changes as much of an indicator of climate change?
Well, in general, you cannot.
Okay.
For example, we've had a particularly severe and unusual winter here in St. Louis this past winter, but you would need to string together, say, 15 out of the next 20 winters of that character before you could say that that's due to a change in climate. So a given weather scenario changes from season to season, as we all know, and from year to year.
Now, Carol, why did you want to make that an important part of the exhibition? Because it happens very beginning at the exhibition here, that everybody who comes through would have a difference, but an understanding of that distinction.
Well, as we were working with the team to develop this exhibit, we recognized that this is one of the places where sometimes the general population, maybe hasn't been in school for a while, looks at an extreme weather day and saying, it's terribly hot today, that's evidence of climate change, or it snowed today and that's evidence that the climate's not changing. And so having people really understand that it's that average over long periods of time where we can see the temperature steadily rise on planet Earth is what was important.
And that's what we want to look at. It's some factors that affect that average over time. And the first of those factors we're going to talk about is carbon footprint, which is a phrase that you're probably hearing more and more in the news all the time. Dr. Dannevik, in a general sense, for those members of the TV or web audience who may not know, what is one's carbon footprint?
Well, the carbon footprint is a way of quantifying how much carbon dioxide and other greenhouse gases are placed into the atmosphere as a result of particular activities that you might engage in your everyday life or in connection with a business or an activity that you're carrying out. So it's a way of understanding your own contribution to greenhouse gas emissions.
And we're going to look at that as we look specifically at this interactive part of the exhibition. I'll turn my back to you guys now. We'll switch cameras a little bit. But this gives us a chance to look at three specific things that affect our carbon footprint. One dealing with the use of light bulbs we have, another dealing with the use of cars, and a third dealing with the use of with the amount of trees that we've got growing. And we wanted our student groups to have a chance to give us some information dealing with any of these areas that we could put into these screens and find out more about it. So if we look at this screen here, we're talking specifically about reducing CO2 emissions, comparing incandescent bulbs to CFL bulbs, or that is, the CFL bulbs that are supposedly way more energy efficient. And an incandescent bulb uses about 104 pounds of CO2 per 1,000 hours of use in the US, while a CFL bulb is 22 pounds. Dr. Dannevik, technically speaking, what's the difference between the two? How does an incandescent bulb work that makes it so different from a CFL?
Well, an incandescent bulb works by passing electric current through tungsten, typically wire, and that creates a good deal of heat as well as a bit of light. And one of the reasons that it's not the most efficient way to produce light is that a fair amount of the current actually goes to producing the heat. In a complex a CFL light, the electric charge is used to ionize gas in the tube, and that creates basically light and very, very little heat. I don't recommend handling a CFL, but I think everybody understands that it's not hot, whereas a tungsten bulb gets very hot.
Well, let's find out what some examples of dealing with light bulbs our student groups might want us to look at. So I'm going to go first to Science Park, then we'll go to Susquehanna in Pennsylvania, and then we'll check to see if Durand, Wisconsin is with us. Do you guys want to put anything into the system about the amount of light bulbs you might have in your house that you'd like to use as an example, or the amount of light bulbs nationally you'd like to look? And I believe it's Janique or Janiqua, I hope I'm pronouncing your name right, who's going to talk to us a little bit from Science Park. What's light bulb information you'd like to give us to put into the system?
Well, you said it right the first time, by the way. But first off, in my household, we have about 10 incandescent light bulbs and only 4 CFL light bulbs, which is, I know it's kind of bad. We should have more CFL, but I mean, it's more convenient at times to buy an incandescent light bulb for anyone in America, really. And as far as the usage, in general, they tend to, the incandescent light bulbs give off more heat, which is more energy, which is almost like you're wasting energy by using incandescent light bulbs instead of the CFL, which are saving energy, really.
That's very well said in terms of the difference between the two light bulbs and the energy use that they definitely have. That's going to be a part of that. I want to go to Susquehanna, Pennsylvania. Susquehanna, do you guys want to go along the scale here and give me an amount of light bulbs you'd like to see, how much they actually produce in terms of carbon footprint? Take it away, Susquehanna.
To start off, we had 15 houses, and we did an average.
Okay.
And we have an average of 15 incandescent light bulbs, and then we have an average of 17 CFLs.
All right, well, let's look at those 15 incandescent light bulbs then, Susquehanna. We go along the slide here, and we do a number increments of 2 here on the computer, so we're going to deal with 16 light bulbs. If I'm able to actually get my finger to go where I want it to. There we go, 16 light bulbs. And we learned that 16 light bulbs annually, for every 1,000 hours of use in the United States, you are creating 1,641 pounds of CO2, enough to fill up 3.2 major big balloons you've got there. So that gives you that information. And if we were to look at CFLs and we were to take that same amount of numbers that you want to change and take 16 again, all the way to the end, then we're actually going to save 1,285 pounds of CO2. So you guys can see then a significant difference in what you're able to save through CFLs with that technology. I want to go up to Durand, Wisconsin. Durand, if you guys are there, do you have any examples you'd like to talk about as we look here at specifically dealing with bulbs and our carbon footprint? Durand, don't forget you can join us via the internet as well, and you can send us your questions that way to live@hectv.org. Let's switch over then, and let's move to the wonderful world of automobiles. And Susquehanna, I'll go back to you guys first. It's interesting to note that every gallon of gasoline burned emits about 19 pounds of CO2. In terms of cars, which would you prefer to deal with? Subcompact, compact, full-size minivan, SUV, truck, or hybrid? Pick the kind of car you want to deal with and give me the amount of miles you might want to look at in terms of people driving. Science Park.
We have 12 compacts.
All right, let's go to
Is
compact.
the average.
All right, let's go to compact cars first. I'll write that down. So we got 12 compact cars, which on average give you 29 miles per gallon. And about how many miles a day are you saying is the average driving for you guys with those?
161 miles.
Oh my gosh, 161 miles. So the scale only takes us to 100. Not to worry, we'll add it all up. So we go 100 miles with those subcompacts. You guys are using 24,417 pounds of CO2 for each vehicle per year. So if we take those 12, I'm going to let you guys do a little math equation. You take that 12 times 24,417, you'll have what that total number is, and you'll notice that that's enough to fill up exactly 2 hot air balloons. That's huge for one car, let alone when you multiply it then by 12. What's another type of vehicle you would like to look at in Science Park?
We would like to look at minivans, and as far as mileage is concerned, about 40 miles per day. So minivans at 4.
A minivan at about 40 miles per day is what I heard. Very good. Let's go to the minivan. Oh, I got to hit that next button. And we'll go to 40 miles per day. And oops. 15,735 pounds of carbon emissions per car. So again, you multiply that out, we're talking about a great deal of difference. Let's go up to Susquehanna, Pennsylvania. Something you'd like to look at, Susquehanna?
How much? It's on. How about
SUVs.
We'll go to SUVs, great, which average about 14 miles per gallon. And what's the average miles per day you're dealing with, you think?
54 miles.
54 miles. Which means that SUV is creating 27,312 pounds of CO2 per year. Multiply that by the amount of SUVs and trucks you might have in your area or in your class, and you see how much you're dealing with. You guys probably have questions for these experts as well as we talk about these topics, so I want to be sure we bring that in also and let Bill and Carol speak more about that before we move to trees. Susquehanna, I'll stay with you guys. Do you have a question for either of our experts about carbon footprint, about light bulbs, or about driving, those areas we've talked about so far? Take it away, Susquehanna.
What is the average person's carbon footprint?
Oh, do we have any sense about an average carbon footprint per person? Do we have a sense of that? Have they done that kind of national statistics? Is that something you came across, Carol, as you were doing any research for the exhibition?
You know, I'm quite sure we did, but I can't recall it right at the moment exactly how much that is. And I know it varies greatly depending on where you live, because there are places here in the United States in particular where we're quite large in our consumption and production of CO2, where that is not true in many other places.
And obviously, depending upon the car you drive, etc., your carbon footprint is going to change. Susquehanna, I'll come back to you guys for more questions. Let's go to Science Park. A question for either of our experts now dealing with carbon footprint. Take it away, Newark.
Overall, I know that your lifestyle actions, such as travel and the use of electricity, and even your diet and clothes affect your carbon footprint. Like, are there any ideas or suggestions you have for us to lower our carbon footprint?
What kind of suggestions do you think make good sense for individuals? That's a great question, Science Park. What kind of suggestions, Dr. Dannevik, for really reducing our carbon footprint? How can I make a difference?
Well, there's several strategies. One is conserving energy. I mean, no matter how the energy is produced, if you use less of it, of course, your carbon footprint is going to diminish. So being smart about turning off lights, being smart about running air conditioning and heating systems, using smart thermostats and strategies like that is one whole collection of ideas there. And then using alternative activities or sources, walking instead of driving, biking instead of driving a car, and so on. So there's conservation sort of comes in several different modalities, and then using alternative sources of energy when they are available.
We had such a conversation with a group of people that I'm working with on the program for lunch today, because we were going to go up to a restaurant that just up a little bit, up the hill, and we were like, oh, should we drive or walk? And we made the commitment today at least, that we would walk there and back since we were dealing with this particular program. Who knows how many of us will remember that tomorrow, but that's where we were today. Let's talk a little bit about trees, because trees absorb CO2. Carol, trees are really important for us in terms of absorption of CO2, right?
Well, as we look at ways that we can help manage the amount of CO2, there's a great deal of work done right now in engineering and research to figure out ways to sequester CO2, to manage CO2. But we also have a natural source that is able to help manage CO2 for us in a very effective way, and those are trees and green plants who need CO2 as part of their life cycle anyway.
And a tree actually removes about 145 pounds of CO2 per year. And so I'm going to go back to Science Park again. Do you have any questions or data about trees you'd like us to put into the system to see how many trees would make a difference in terms of carbon footprint?
I would like to compare if you had 3 trees in your yard compared to if you had 10 trees in your yard.
All right, that's a great specific example. Let's compare 3 trees to 10 trees. So if we move along the scale here, we're going to notice, for example, if we talked about 4 trees, that you're actually going to absorb 580 pounds of carbon dioxide per year. And if you have 10 trees, you're going to absorb 1,450 pounds of carbon dioxide a year. So that does indeed make a significant difference. Plus, you can also think about the fact, Dr. Dannevik, that trees in your yard also help reduce carbon footprint in other ways, because if I've got a more shaded house, it might mean that I don't have to run my heat as much or my air conditioner as much, that kind of thing.
Yeah, that's a very good point. And something that's not often appreciated about this particular way of absorbing carbon is that it is temporary, in the sense that the tree will take up the carbon as it grows, but when it dies and decays, it returns the carbon back to the Earth system. But that's a very helpful service it's doing for us, because what we need is time. We need time to develop the alternative energies that are economical and efficient, and storing carbon even temporarily, even if it's for a couple of decades or the typical lifetime of a forest or a tree individually, that can be very helpful.
Cool. Susquehanna, Pennsylvania, let's go to you guys. A question about trees or carbon footprint, or an example you'd like us to check out here.
Which tree absorbs the most carbon dioxide?
Oh, that's an interesting question. I'm not sure that there's a distinction. Is there a difference in the kind of tree? Like, do certain trees absorb carbon dioxide better? That may or may not be in your area of expertise, Mr. Meteorology. But
I suspect there is some difference, especially between conifer and deciduous trees. I would guess that there's a difference in how much they absorb, but it's not my area.
Okay, so now based on the different, a conifer tree, of course, being like a pine tree, those kinds of things, a deciduous one that drops its leaves in the wintertime, I'm assuming, this would be my hopefully educated guess, that a conifer would absorb more CO2 because it doesn't drop its leaves, or is that
possibly? Maybe
not?
Yeah, it's a complicated question.
Okay.
And I don't know the answer for sure. I'm just sort of taking a guess that they would be different.
Okay.
Don't know which way it would go.
Cool, that's an interesting research question perhaps for our students to deal with. So we're going to move away from carbon footprint now and begin to move to our second area dealing with rising sea level. And as we do that, we want to let you guys see a little bit more of the exhibition that we'll be walking through as Carol and Dr. Dannevik and I do that. And as we begin to move to this next area and we look at more things that are in it, Dr. Dannevik, and we think in terms of like carbon footprint and its effect on the Earth. You know, there's that whole question about, climate change, man-made, climate change, natural, that kind of thing. How is the research actually like ferreting out the difference? Is there a way to determine percentage, for example, or anything like that?
Well, what you're referring to is a very important fact, and that's that we know the climate varies naturally. Even if we're not messing around with the composition of the atmosphere, we know from geologic records that the climate has been different in the past. So one of the ways that researchers are trying to distinguish what might be climate change due to greenhouse gas emissions from natural climate change is that the spatial pattern of the temperature change would be different in those two cases. So by looking at how is the temperature change distributed geographically and with altitude, you can go some distance toward discriminating between natural climate variability and that due to greenhouse emissions.
Okay, that's interesting, and an interesting topic for people to pursue as you begin your own research into it and think about best policy options. A second major area that is affected by climate change we wanted to talk about in today's program is rising sea levels. Because as temperature of the Earth rises, what happens is we get more ice melting, correct, Dr. Dannevik? And as a result, sea level will rise over time and coastal communities might be very affected. But we're talking here about like permafrost or ice on land, right?
That's correct. Ice that's already in the ocean, like icebergs, so to speak, melting does not really add to the mass of water in the ocean, so it doesn't increase sea level. It's only when ice melts that has previously been on land and then the runoff ends up in the ocean that you increase sea level.
We wanted to look at two different examples in regard to rising sea level. One was dealing with human habitation, specifically the island of Manhattan, which of course as an island has to deal with sea level all the time, and a second dealing with animal habitation in the Arctic Circle, polar bears, which are an extremely important part of the research that's going on right now with climate change anyway. You all received a map of Manhattan in advance, and I want to go to Science Park first to find out about a couple of the locations on the island that we're interested in. We'll bring up a map of Manhattan Island. You see the entire map of Manhattan Island now. And now we'll zoom in a little bit from the entire map of Manhattan and go to the numbered locations that we sent to you guys in advance. And let's go to, I believe it's Jamie, it might be Jaime, joining us from Science Park. What are the first two locations on the map? Locations 1 and 2. Could you identify that for the world for us?
Well, the first location is the Empire State Building, and the second location is the Chrysler Building.
The first one is indeed the Empire State Building. The second one, and that may or may not be easy to deal with the map, the second one is specifically Rockefeller Center, that whole area where NBC is as part of the island of Manhattan. And we wanted to put those kind of locations there because obviously there's significant businesses that happen at those places that would make a big, big difference. We'll come back to you guys in a minute. I want to go to Susquehanna, Pennsylvania. Did you have a chance to look at the numbered map in advance? And if so, what are locations 3 and 4?
3 is the World Trade Center, and 4 is the Metropolitan Museum of Art.
That's exactly right. 3 is the World Trade Center, 4 is the Metropolitan Museum of Art. And we wanted again to think about different kinds of human activity that really matter. Obviously the economy, world trade, all of the financial district that happens around there, exceptionally important. But then you also have to deal with major cultural artifacts, the hugely phenomenal artistic resources. I mean, if the Metropolitan went underwater quickly, you'd lose Starry Night from Van Gogh, amongst other things, which would matter to a great many of us, I'll admit to being affected by that. So we wanted you to look at those locations. We then wanted you guys to have a chance to find other locations and place them on the map. So Susquehanna, I'll stay with you and then I'll move to Science Park. Let's look at the first couple of those locations. In terms of Wall Street, why do you think Wall Street's important? Why would we care about that? And where on the map of location would Wall Street be located?
It's important because it's for the financial district and it's where the stock market is.
Right, it's where the stock market is, and if we go back to the numbered map of Manhattan, you can actually see the Wall Street is located obviously just south of where the World Trade Center would be, a little bit south and a little bit east of the World Trade Center is where Wall Street, the heart of the financial district, is. Susquehanna's second area on that map we were interested in people looking at is Pennsylvania Station. Why do you think Pennsylvania Station would matter as a location?
It's a major way of transportation around Manhattan.
Correct. 600,000 passengers go through Pennsylvania Station on a daily basis. And we bring up this map that we've got in Manhattan which shows all of these locations on it. And you'll see Pennsylvania Station is where Pennsylvania Station is located. Science Park, I'll go back to you guys to look at the couple of other locations that were intriguing to us. Why do you think we asked you to think about Times Square? Why would Times Square matter as a location?
Times Square will matter as a location because it's a very big tourist attraction worldwide. And in that sense, it will truly help the economy of New York because if you have all these tourists coming, they're obviously going to consume other things that area might serve, and it's just a big tourist attraction overall.
Very good information in terms of Times Square, an exceptionally important location. And the last one we mentioned is Staten Island Ferry Terminal. Science Park, why does that matter?
Well, Staten Island Ferry Terminal is important because just of the fact that a lot of people commute from the outskirts of Manhattan, not just, in this sense it's Staten Island where you have a lot of people coming from that area, which is highly suburban, coming to the city to work. And it's just a big commuting thing, the ferry terminal.
Yeah, it's basically the major lifeline between obviously the island of Manhattan and Staten Island itself where a significant amount of people live. So we wanted you to be aware of that and let the world be aware of it as we think in terms of what might happen if sea levels start to rise. Now Carol, we've got a model over here which shows part of the island of Manhattan, and it actually demonstrates rising sea level at different levels, right? Why did this model become important to you, and why do you think it's important that we have a chance to look at the impact that sea level might make?
Well, we thought from metropolitan area that it was very important for people to sort of see a model of what would happen if the sea level would rise 5 meters 15 feet or 3 meters, closer to 10? And how many buildings would that really impact? For us as consumers to look at a model, it's very helpful for us to see what happens. But models are also important to scientists. And as scientists try to figure out how we will manage rising sea level, whether they're architects or they're city planners or they're scientists that are thinking about construction, having a model is a good way to begin to understand the impact.
Well, let's begin. We'll move closer to this model as we begin to ask you questions about what this area of Manhattan might represent. We're going to give you 5 kind of shortened views of the Manhattan location we just had. And as you look at this location, it will ask you to make hopefully a somewhat educated guess, though it may not be easy necessarily to pick out what those things are. But based on what we see here, what part of Manhattan might this represent? So option 1 takes you up to obviously where the Empire State Building is in New York City, that part of Manhattan Island. Option 2 takes you further north on Manhattan to the Rockefeller Center. Option 3 takes you back south down to the World Trade Center. Option 4 takes you all the way north into Central Park, where you see the Metropolitan in the upper right-hand part of your screen. And then option 5 is actually halfway between what would be the Empire State Building and the World Trade Center. Compare those images to what we see here. I'll go to Susquehanna first and then Science Park. I'll go to you guys. Which of those options do you think this part of Manhattan might represent? How much of Manhattan might we be seeing here? What do you think, Susquehanna?
We can see the Empire State Building.
Okay, so you guys are thinking it's all the way up to option 3, potentially the Empire State Building. And I think I can see what building you're looking at, which might make you think that, so that's a cool thing to know. Science Park, the same hypothesis or a different one? Are you able to still hear? You think it's up to the Empire State Building as well, Science Park?
Yeah.
Okay, very cool. And I'm assuming that maybe the reason you're thinking Empire State Building is because of this building right here. But this actually represents the island of Manhattan only below Chambers Street, which if we go back, if we go to that diagram, if we go to the map of Manhattan below Chambers Street, you'll see the location of the former World Trade Center. And so it's pretty much the financial district of Manhattan. 55,000 people do reside in this section of Manhattan, but it's much more about financial district and the industry that's applied to that. And then, of course, you've got to remember that in addition, and one of the reasons we wanted you to think about Pennsylvania Station or all of these other locations as well is because New York is obviously a place that's really dependent on rail transportation and, of course, the subway system. And so as we think about sea level rising, we're thinking not just about what's going to be affected above ground, but obviously the subways won't be running in New York either. I want to go to your guys' questions that you might have about sea level rise in general before we move to talking about polar bears. But Dr. Dannevik, before we do that, as we think in terms of sea level rise, I mean, this is for the most part going to be a slow transition over time, right? Do we have any kind of sense about the amount of time and what kinds of things are being done scientifically to monitor progress? Like actually, do we have monitors places around the world?
Well, we are measuring sea level at many locations, and one fact, however, is that the record doesn't go back a great number of decades, so it's a little hard in some cases to make the comparisons. Sea level rises for 2 different reasons when the planet warms. One is that water expands naturally when you increase its temperature, so there's a small amount of systematic but rather slow sea level rise associated with just warming the planet up. Okay. And the other source that gets most of the publicity is the possibility of melting ice that is presently on land and then the runoff going into the ocean. Now that can occur on different timescales. If there is a sudden slippage, so to speak, of the ice mass or a portion of it that's on Greenland, for example, that would drop into the ocean and that would bring about a rather quick sea level rise. The expansion due to just increased temperature would happen over many decades and perhaps would be quite manageable for many countries.
All right. Let's see what questions you all have about sea level rise as we'll begin to move to the polar bear part of the exhibition. Science Park, we'll start with you guys. A question for our experts about sea level?
As one of the experts stated that the ice that melts in the sea doesn't affect the rise in sea level. So we wanted to know around how is the time scale of ice that melts inland, how does that affect the sea? How is the time scale? Does it take long for the sea level to rise if it's not coming from the ice that's in the sea?
No,
from the icebergs.
Yes, ice that's already in the ocean.
The ice that's already in the ocean melting doesn't affect, so
right.
We're talking about the ice that's on land is making all the difference.
That's right.
So we're dealing with permafrost, we're dealing with ice that would be glaciers in Greenland or glaciers in Canada or whatever the case may be.
Right. And on Antarctica.
So any sense over time have they done any kind of models that indicate how much time it would take for the sea level to rise?
Well, if you know how much ice is being melted, it's a very simple calculation to calculate the sea level rise. The real trick is modeling and predicting the rate at which the melting will occur, and whether there'll be any what we would call catastrophic changes, that is, changes of very large masses of ice over a short period of time, such as I mentioned, a wholesale slippage of a very large shelf of ice off of a landmass into the ocean.
Okay.
That would happen very quickly, possibly over just a couple of days.
So there's like a mathematical formula which would tell me if I lose, like, I don't know, 10 miles of ice, slips into the ocean and starts to melt, I could expect X amount of sea level rise from that?
Right, yes.
Okay.
Those models are somewhat straightforward. It's the difficult part is predicting when the ice will slip off of the continent, so to speak.
All right. Thanks for that question, Science Park. Let's go to Susquehanna. A question from you all about sea level rise?
Since you started recording the sea level, have you seen any changes?
That's a great question. Since the time of when records of sea level began, we actually noted it. Have we seen an actual rise in sea level over that period of time?
We have seen, I think the popular number is around 15 centimeters over, I'm guessing about a century.
Okay.
Most of which occurred in the last 4 or 5 decades.
Now 15 centimeters doesn't seem like very much to me. I mean,
it's just about 5 inches.
It's about 5 inches, 15 centimeters is 5 inches. So then, Carol, obviously we're talking about a lot of island nations. That 5 inches could make a big difference, potentially.
Well, if you look around the world, there are a number of island communities where the actual difference between the shore and an inland area may only be a couple of meters.
Okay.
So then if you have a rise in sea level, you begin to have a huge impact, not only in terms of water encroaching on territory, but water that seeps into the aquifer and begins to change how it's possible to raise crops and water systems that are used for fresh water on those islands. And then it's a really big deal for them.
Well, remember, Tim, much of the country of Bangladesh is only about 100 centimeters above sea level.
The country of Bangladesh is only about 100 centimeters.
Major
portions about 100 centimeters.
Right.
So a 5 centimeter difference.
15 starts to make a difference.
15 starts to make a difference. That's really good specific information to know. It wasn't just human habitation we thought about. We also wanted to look at animal habitation. And so obviously polar bears are an extremely important part of what we're looking into in terms of climate change. And we've got some images of polar bears here for you guys to see, obviously. Polar bears live about 20 to 25 years. A good adult male polar bear might be as much as 10 feet tall and is going to weigh anywhere between 550 and 1,700 pounds. And we're interested in what questions you guys might have about polar bears. We've got a map that shows you the Arctic Circle, because obviously polar bears live in the Arctic, and then this next map shows you the different populations of polar bears as they herd out into different areas. And as we think about polar bears and what happens with them, obviously, we need to be concerned with what they are as an arbiter or indicator of what might be happening in climate change as well. And one of the big questions that a lot of people have is the ice flows that are affected as a result of climate change and rising temperature. This image of polar bears on ice flows kind of sets up that topic a lot. How do the ice flows matter so much to polar bears, Doctor?
Well, ice flows are a part of the natural habitat of the polar bear, and they, sometimes you'll see them floating around on it. They're in most cases resting from having been swimming for quite some time. But they use the icebergs as sort of a temporary resting place and other activities as they go basically hunting.
Okay.
So ice is a very important, as we all know, aspect of their natural habitat.
So that inability to rest on the ice floe means they've got to spend more time in the water, they're swimming more, etc. It changes their life habits?
Or it may change the regions from which it is feasible to do their hunting.
Oh, so it changes where the population needs to go and where the population needs to live.
Right.
Okay. Let's see what questions students might have about the Arctic ice cap melting, sea level rise, and the changes that might happen economically or environmentally because of that. I'll stay at Science Park and then I'll go up to Susquehanna. Science Park, any questions about Arctic sea level rise or polar bear regions?
Well, I researched and found that polar bears walk about 5 to 6 kilometers per hour. So since there are less ice caps and less ice for them to walk on, is this affecting how much they swim per hour? And also, is this affecting how much or where they are able to rest?
So that's excellent research and also the question. So does this affect, one, how much they're able to rest as well as where? Does it change the way, like how much they have to swim or the miles per hour they can swim? And I mean, does it affect, do we have heart rate or whatever the case may be, all those kinds of things?
Well, it's not my field of expertise, but I think that's a good list of things that do get affected, and in combination. So it's a very complicated interaction. Maybe Carol has some more information on that.
The other reason we put this iconic piece here in the exhibit is because when their hunting grounds are affected, when the normal places where they can carry on what is a normal flow of life becomes disrupted, then they begin to look for alternatives. And when your alternative is the trash dump in a local community, that's not the same healthful living that we would want for that polar bear. So in the long run, it's hard on their health as well.
Right, and that's happening in like northern communities in Alaska and Canada. I understand polar bear populations are shifting a bit south, and they've actually experienced that, of them coming into their trash dumps and things.
Absolutely, and in some ways this is sort of easy, but it's also not appropriate. It's not good for their nutrition. It's not what really would sustain them over time.
Okay, very cool. Susquehanna, Pennsylvania, a question for you guys about the Arctic environment and sea level rise. Go right ahead.
Since the polar bears have to swim to the ice caps to find for their environment, and they've been melting, have we set up any program to actually help them
So we're talking in terms of programs to help polar bears adapt or deal with the fact, are efforts happening? Are either one of you familiar with efforts that are happening dealing with helping polar bears adapt to the situation that's occurring to them?
I'm not aware myself, but I bet there are.
I'm not aware of that, but I do know that there are certainly efforts to discourage them from becoming too adapted to being around humans, because when that happens, they begin to change in terms of the way they hunt, but also they become fearless of humans, and then oftentimes they're considered a danger and they eliminate them. So we really want to encourage, and there are efforts underway to help polar bears think of another choice besides being on the trash dump.
And economically speaking, one of the things that people are potentially have a source of contention over is the fact that we may not necessarily have ice throughout the winter all the time there now, and so it actually becomes a method of transportation and commerce that could make a big difference.
Right, shipping routes that were not feasible before are starting to look like they might be feasible again. Trans-Arctic shipping routes.
And then, just what are Canadian rights in that regard up in the Arctic Circle versus American rights, Russian rights, etc. becomes an interesting political topic as well. If you guys have more questions about sea level rise, don't forget you can always email them to us at live@hectv.org. And if we get email questions during the program, some folks can feel free to check my computer and put those into my ear. We want to talk a little bit about solutions now and alternative energy sources. So we're going to move to that section of the exhibition while you see some more of the exhibition itself. And Carol, as we walk through this section and the students see the video, we're dealing with oceans here, the coral reefs, and we're also dealing with how climate change would affect land. Why did you really want them to have a sense about oceanic versus land differences?
Well, just as trees make use of CO2, the ocean is a great collector of carbon dioxide. But when you're adding carbon dioxide to the ocean, you begin to change its chemical composition. And so we wanted to point out the potential that has for fragile areas like coral reefs, where the coral themselves can only sustain a certain range of acidity, which the carbon dioxide adds to the ocean.
Okay. And as we enter now the alternative energy source area of the exhibition, you're going to notice that there's all sorts of alternative energy that are highlighted here that you could choose to find out information about, whether it's the solar panel array, geothermal, an example of a wind turbine. But today what we're going to focus on is nuclear energy, and thanks to Science Park for sending us that suggestion. And we're standing in front of here of a model of the core of a pebble bed nuclear reactor. And Science Park, I want to go to you guys in terms of why you thought nuclear power was an interesting one to talk about. Give us a little bit of information on nuclear power, what your decision was in that regard. And if you've got an opening question about nuclear power, we'll begin to answer those questions, and then we'll go to Susquehanna. So take it away, Science Park.
Well, due to the recent events in Japan, we felt that talking about nuclear power was appropriate for this conference.
I agree with the recent incidents in Japan. Nuclear power is certainly appropriate. Let's talk a little bit to give some students some background information about nuclear power systems and how they work. We've got some images from the Callaway nuclear power plant, which is located in central Missouri. If you were to travel out I-70 west, just about not an hour and a half, you would actually see the Callaway nuclear power plant off to your left, to the south, as you were traveling I-70 from St. Louis to Kansas City. And so the first image shows you that power plant from the Earth. It's a Google Earth image. And our thanks to Google Earth for providing that image of the Callaway power plant. And as we look at these images, Bill, maybe you could talk about the basics of what exists in a power plant as well. And because we'll just go through these images and show them from the air and all those kinds of things. So what's in a power plant?
Well, the generation of electricity by nuclear fission is a process which involves splitting atoms that are provided in the fuel, which is typically some form of uranium or related material. And in that process of splitting the atom releases a lot of energy, and that becomes internal energy, which we call heat, better known as heat. And so that fuel, as it breaks down into other materials, provides a heat source which is then used to heat water, which typically then drives a steam-powered generator, which in turn turns a turbine, which then in turn turns a electric generator. There's another form of nuclear energy that isn't real yet, and that's fusion energy, and that involves, instead of splitting atoms apart, putting them together, and it also, through a different process, produces a great deal of energy. That one is thought to be out there in the future, but it's very hard technically to achieve.
When we look at some of these images again, and I'll ask us to bring up the one that's the nuclear aerial image, where we can really see a nice one from the air. I'm going to notice two major structures. There's this tower where it's like steam coming out of it, and then there's this round like containment location. What are those two places, and how do they operate in the system?
Well, the containment, the dome-like structure, is the concrete and steel containment structure for the nuclear fuel rods themselves. And so inside there is the nuclear fuel and the heat exchangers and so on that basically bring the hot water out of the system. The large tower is a cooling tower, essentially.
And then you'll notice in the image that I've called Nuclear 2, we see how the nuclear power plant connects to the electrical grid, because remember, with any alternative form of energy we're talking about, we're basically talking about how we can create electricity, correct?
Yes, yes.
So they've all got to connect to the grid in some way. Carol, why did you think it was important that people have a sense of different kinds of alternative sources before we take some student questions?
Well, as you walk through this exhibit, you're obviously impressed that the Earth's climate is changing and that it's important for us to think about what we can do about it. And we didn't want people to leave the exhibition thinking there wasn't anything you could do about it. There are certainly alternatives for us to think about. And as we talk about sustaining the Earth, we want to have as many options as possible. I do think that one of the things important to note about these various forms of alternative energy is that it isn't free to get energy from one place to another. And so as you looked around this exhibit, you can see that various kinds are more appropriate in some places than others.
Right, and obviously nuclear power is one of those things that I could cite in almost any location. I might obviously have real issues about the location itself, and they might be having those conversations now in Japan and other places about siting it close to coastlines, siting it dealing with earthquake faults, but in a way, obviously, hydropower has to exist where a river is. Geothermal energy obviously has to exist where I've got the possibility for that to come up. And wind turbines can't just exist anywhere to create a certain amount of electricity. I mean, in Missouri, for example, the major wind farm area, I understand, is the northwest part of the of the state, where there's actually some nice wind farms up that way.
That's right.
And so it varies, obviously, by location. What questions do you guys have about nuclear power first? And then there's some questions on other alternative sources. Please ask them. We'll go to Science Park for 2 questions, and then we'll go to Susquehanna for 2. Take it away, New Jersey.
We wanted to know, where do you guys believe is the best area to set up a nuclear power plant?
All right, Dr. Dannevik, what would be a good area, a safe area, the best area, as they say in Science Park, for setting up a nuclear power plant?
Well, I think it would be an area that is not subject to natural hazards such as flooding or earthquakes. I mean, this is in the ideal world. You would want to find places that aren't subject to natural hazards, not wildfires. You know, don't site them next to a forest that's dried out, etc. So that would be the ideal.
Okay.
The other thing, though, you have to sort of balance that against the need that Carol mentioned for the plant needs to be near where the electricity is needed. So it doesn't help to put it out in the middle of the desert of New Mexico if there isn't a nearby population that can benefit from the electricity without there being a lot of loss as it's transmitted from one location to a distant
Good. That's what I wanted
user.
you to talk about. The distance matters because I'm losing I'm losing power, so to speak. I'm losing electrical generation the further it goes along the lines.
Yes.
And that's why there's like substations and stuff for like electrical lines,
That's
right?
to boost the power that has been lost, yes.
Okay. Good question, Science Park. Let's go to your second one right now.
What are some safety measures that could be taken to prevent a nuclear meltdown?
Safety measures. Well, we can go to the image that you see of the nuclear control room. We've got a picture of a nuclear control room. This is actually a simulation of the nuclear control room in Callaway. It's not the room itself, but they have a training simulator that they use, and this is an image of the simulator. So when we think about safety measures, and we think specifically about Japan, for example, there are all sorts of safety measures that go into effect, because my understanding is that the Japanese nuclear power plants, the 3 reactors that were running, did immediately shut down when the earthquake happened, right?
That's correct, yes.
And so the issue became for them, talk about other safety controls that are there, because they're having a significant issue dealing with cooling because they lost their power generation system.
They lost their power supply from the grid,
okay.
And they had a number of backup options available to them as a second and third option. For example, they could start up their diesel generators to supply the electricity. You could also go to batteries if you can't, for some reason, use those. So all of those are needed to drive pumps which help cool the system by flowing water throughout the reactor system.
And in the very little bit I've been trying to understand in the course of what's happened in Japan, we're talking extremely hot temperatures, right?
Yes, we are.
How hot?
Don't know the answer, but it's hot enough to melt most of the metals that are involved in the construction of the reactor itself.
Okay, and when you hear the term meltdown, when I'm hearing partial meltdown, they talk about Chernobyl meltdown. What's actually happening there is that literally the temperature becomes so great that there's a meltdown through the bottom of the containment unit?
Well, not necessarily through the bottom.
Okay.
I think the meltdown term itself, which is used a little bit more loosely than we would like in the general community, but I think the meltdown that the engineers are talking about, first of all, is the melting of the fuel rods themselves.
Okay.
So the fuel rod and its associated support might melt, and in principle that could mean it could just pool at the bottom of the containment vessel. So that doesn't necessarily mean that you've lost the radiation or the radioactive materials to the environment.
Okay.
If the containment vessel is still intact and functioning correctly, then it's still okay. It's been a meltdown, but it hasn't been released.
All right.
The danger, many dangers, but one of the dangers is if the containment structure itself is compromised by means of an explosion or an earthquake, for example, and develops some sort of breach, then the materials can leak out.
Okay.
Then you have a different scale of problem.
Susquehanna, let's see a couple of questions that you guys have about nuclear power or another form of alternative energy. Go right ahead, Pennsylvania. What's your first one?
After what happened in Japan, are we taking some way of reducing the use of nuclear power, and are we not going to build as many plants?
That's obviously a question that a lot of people are talking about now after the incident in Japan. What's the conversation in the United States and other places about reducing nuclear power use and that kind of thing? As you look at it, Carol, what would be your responses to looking at this event and then thinking about what kinds of policy standards, or the way, a review, I guess. How would you go about reviewing what's acceptable or not, safe or not, that kind of thing?
Well, it's obvious that in many places in the world today they are doing just that. Europe announced they're going to go back and review a number of their power plants. 70% of the electric power in France is produced by nuclear power. So it is important for everyone to look, including here in the United States. One of the things that can happen at a science center is to provide an opportunity for people to have conversations, to talk about the things they're worried about, the kinds of questions they want to have answered. And I'm quite sure that over the coming weeks, the United States will spend a good deal of time talking about the safety measures we have in place, whether or not they're adequate, and to look at what is the future for nuclear power as a potential here for us.
I know I've heard lots of conversation about, American nuclear safety regulations and how efficient and effective they are. I know that in Germany, Chancellor Merkel decided to shut down for inspections the 7 that are older than 1980, were built before 1980, because it's my understanding that one of the issues dealing with the wasted fuel rods in Japan is the location of those wasted fuel rods in the plant in relationship to the fuel core itself, right?
Yes.
The reactor itself. Like, here's the reactor, and then there's a bunch of concrete, and then over here's where we've stored the fuel rods, and we don't do it that way now, but in older plants that has happened,
right?
That's
right. The plants built in the era of the 70s, many of them had this design aspect to them, that the spent nuclear fuel was stored nearby, outside the containment vessel, but nearby the reactor. And later it was maybe realized that there are better options for that, and I think typically now they're stored underground, in both cases covered with 20 or 30 feet of water.
And that water makes a huge difference because they stay hot a long time.
They do. Even though it's spent fuel from the standpoint of being able to use it in the nuclear reactor, it's still very radioactive and dangerous material.
Okay. Susquehanna, a second question from you. Go right ahead, Pennsylvania.
Are there any other fissionable materials that can be used that don't give off as much radiation as uranium?
Oh, in terms of fissile materials, uranium, are there any other materials that wouldn't produce as much radioactivity? Good, interesting question.
Interesting question. I'm not a nuclear engineer myself, so I don't have the answer to that. There are various grades of uranium that are used in different types of reactors, but my guess is, and it's a guess, is that it's predominantly uranium. There may be some plutonium in some of the reactors.
I heard a little bit of conversation about plutonium in some of the Japanese reactors.
Right.
That plutonium was being used too. We want you guys to think, as we come toward the end of the program, about solutions, obviously. I'm going to walk over here to this board and invite Carol and Dr. Dannevik to join us. This board represents all sorts of young folks who have come through the exhibition who have offered specific solutions that they've posted up here over the course of time. And Carol, why did you think this was important? Why did you want this to happen?
Well, we realized as people went through this exhibit, they started to think, and they had good ideas, or they wanted to make a commitment to live in a different way and to help control their own use of carbon and reduce their carbon footprint. So we wanted an opportunity for for people to express their ideas. And the staff here at the Science Center regularly reads all of these, and we're looking at ways those can help us plan other things to do here at the Science Center.
Well, we want to give you guys a chance to do the same thing as we come toward the end of the program, so I want to go to each of our groups for a final question you might have about any alternative forms of energy or any subject we've talked about today. And if you guys have a suggestion for what we could do, what actions we could take, I'll write it down and we'll post it up here, and we'll mention it Susquehanna, Pennsylvania, or Science Park in Newark, New Jersey, and let everybody know what your thoughts are. So I'll start by going to Susquehanna, and then we'll end in Newark. Susquehanna, a final question from you guys, or a suggestion for what the world should do that you'd like us to put here? Take it away.
Which alternate energy is the most environmentally friendly? Not in the form of giving off emissions, just its presence being in the environment.
Which form of alternative energy is the most environmentally safe one? That obviously could vary in a lot of conversations. Carol, and one thing you need to think about always is that not one form of alternative energy is going to make the difference for all this. Carol, we've got to replace a lot, so it's really probably a mix and match we're talking about.
It's definitely a mix. There are places, for example, where geothermal is available, and it's a very safe alternative. There are many who still believe that nuclear energy is, in terms of the amount of carbon dioxide that is not emitted, is also very safe and appropriate for the long-term health of the Earth. But there are always trade-offs. There are always expenses, and there are always choices that you have to weigh between one and the other as you make a decision.
If I put you on the spot, Dr. Dannevik, and said, pick the most environmentally friendly and no, I won't let you hedge, what would your answer be?
I would say solar photovoltaic.
Okay.
But one thing I wanted to mention, when you talk about how green is a particular energy technology, it's important to look at what we would call the life cycle cost of the source of energy. And that means not just looking at how much carbon dioxide does it emit or other environmental effects as you're using it, but what about the cost of manufacturing the device itself? What about the cost of disposal? And if you find a way to measure all three aspects of that, manufacture or creation, use, and then disposal, that's a more integrated way of looking at the environmental impact of for example, the nuclear fuel disposal is a real dilemma.
Right.
Right now, there's not a real good solution to what do we do with this stuff. So it's stored typically on site, and it accumulates. And it's not a great thing to be accumulating, basically. But right now, we haven't really come up with a viable alternative.
Good question. Science Park, I'll let you guys end with a final question and or comment you wish us to put on the board. What would that be, Science Park?
It's not so much of a question, but it's more a suggestion to the people of our country. I know the term going green is getting a little old and everyone is trying to go green, but that really is a key. Like, we need to practice more sustainability and just be more accountable of our actions and how they affect our environment. Things just like I said previously, but the clothes we wear, the food we eat, those things are transported, and transported how? Using fossil fuels. So some of the things that we use are indirectly affecting our environment. So we have to find a way to bypass the usage of so many fossil fuels, of so many nuclear energies, because overall it's affecting our environment greatly, and slowly, if the weather changes continue, eventually it's going to affect our climate.
Thank you so much for that. I'm writing down as fast as I can, Science Park, to get that in there, and I can write that in then and put it up here so that the rest of the world will see it. Newark, New Jersey, via video conference, 3/16/2011. And where's a nice...
Why don't we just take one of these
We'll
down
take one of these
here,
down and we'll
right?
put you right here in the center, because indeed the practice of sustainability, being aware of how different things affect the environment and really taking the steps makes a big difference. And so in lots of ways that you can think about doing that. We really appreciate the fact that both of you were able to join us today from Susquehanna, Pennsylvania, and obviously from Science Park. And if you joined us via the web or television, we appreciate your attendance as well, and thanks for being part of the program. This program will be archived and available on our hectv.org website about 2 weeks from now, so you can refer to it back again. It'll also be on our Education HEC TV page on iTunes U, where it'll be available for free download. And I just want to thank Dr. Dannevik so much for being with us. And Carol, thank you so much. If people come to St. Louis and they want to come to the Science Center, it is of course free admission, believe it or not, and you're open Monday through Sunday, the whole week?
We're open every day of the week, and every day of the year except Christmas.
And how long does the climate change exist?
This will be here until the middle of May.
Okay.
So we encourage people to come and see the exhibit, and there's no cost to come.
Thanks so much for being with us. We're going to take a short break for HEC TV Live over the course of the next couple of weeks while all sorts of schools experience their spring breaks, but we'll be back in April for something very different. We'll be talking about jazz music with Inside the Artist Studio from Jazz St. Louis, and then at the end of April, we'll be back working with the Science Center again for programs related to FIRST Robotics, the engineering competition that high school students do, so you can learn about robotics and science and engineering. That'll be really cool and really fascinating. As we end this program, we want to send a special thank you and shout out to our tech director, Drew Unser, who's been with us since the beginning of HEC TV Live. This is about the 105th program for HEC TV Live. He's leaving at the end of the month to head out to Los Angeles. We wish him the best, and we thank him so much for being a part of the program. You're what makes it all very successful. Thanks everybody for joining HEC TV Live. We look forward to connecting with you again.